Let's have a look at this example from section 2.6. The topic of section 2.6 is continuity, and there are a variety of types of examples that we find there. I want to look at this particular one because what I've found in the past is students often find this challenging, and I think this is a good example, if you understand it, to really get a handle on what it means to look at a piecewise defined function and decide whether we have continuity at a point. So here we have this piecewise defined function, okay, which again just means that you've got a function that the rule that we have to follow depends on what interval x is in. Okay, so if x is less than 1, we have one rule. If x is equal to 1, we've got another rule, and if x is greater than 1, we have a third rule. And we're going to need to keep that in mind as we look at the limits. So part A says determine the value of a for which g is continuous from the left at x equals 1. And to be continuous from the left means that the limit as x approaches 1 in this case from the left is going to be the same as the value that the function takes at 1. And let me just start by just noting that g of 1 is a. Okay, that's just right there from the definition of the function. The limit as x approaches 1 from the left of g of x. Okay, well, we need to know this, and we want to make that equal to, or we want to know what value a needs to take for those two things to be equal. And to know what the limit as x approaches 1 from the left of g of x is, we need to look back at how g is defined and say to ourselves, well, if x is less than 1, because we're approaching from the left, what rule do we have to follow? Well, g is x squared plus x if x is less than 1. So this is the same as the limit as x approaches 1 from the left of x squared plus x. Now that's a polynomial, and to get that limit, we can simply plug in 1, and that limit is 2. So for these two things to be the same, we need a to be equal to 2. Okay, that will make g continuous from the left at 1. Now, part B over here asks the same question about continuity from the right. So we're going to do something similar. Again, we can observe that g of 1 is a. The limit as x approaches 1 from the right of g of g of x. Well, now we have a different rule to follow, because when x is greater than 1, g of x is 3x plus 5. So now we're going to do the limit as x approaches 1 from the right of 3x plus 5. Again, that's a polynomial, so we can just substitute right in and get our limit of 8. Okay. So now we see that our answer to part B is that a is equal to 8. That would be the value of a that would be required to get continuity from the right. So to finish this problem off, it says, is there a value a for which g is continuous at 1? Well, based on our answers for a and b, we would have to say no, because there's one value of a it gives us continuity from the left. There's a different value of a that gives continuity from the right, and since the limit as x approaches 1 of g of x does not exist, because those one-sided limits are different, so g cannot be continuous. x equals 1. Okay. Again, I think if you understand this problem, then the concept of continuity for piecewise defined functions should be clearer after kind of reviewing this problem. I hope that helped, and I'll see you in the next video.